Hello Sparkies and Giganeers. You all know about our brilliant offers like Spotify and 4G, which make having a mobile with us pretty awesome. Offers like these play a big role in getting us closer to our goal of unleashing New Zealand's potential. What you possibly don't know so much about is the engine that drives it all. The wind beneath the Spotify wings, the brains behind the beauty. Okay, you get my point. Well, I'm here to tell you that it's worth knowing about, because it's really impressive, and it's a key reason we can say with confidence that we will unleash all that potential. I'm talking about our mobile network. Unfortunately, there'll be no diploma in engineering at the end of this short lesson, but you will be able to explain the key components of our network, and boast with pride that you are part of something really big and impressive that we can all be proud of. Let's take a closer look at our mobile network. Unlike a walkie-talkie, mobile devices cannot communicate directly with each other to make calls. That is where the mobile network comes in. There are many components to our network, but for the sake of keeping it simple, we're going to break it down into sections. First, we'll look at the bits you use every day, including mobile devices and SIM cards. Then we'll have a look at the radio access network. This includes the cell sites you may have seen dotted across the country. Last, we'll have a look at the network core. The network core houses many systems that do loads of things, like authenticate users and sending calls, texts and data to the rest of our network and onto other networks. As you learn about the different components, keep in mind that our network is evolving and is constantly being monitored and optimized to provide the best capacity and service for our customers, as well as adopting new technologies like 4G. Okay, let's start with mobile devices and SIM cards. In network speak, these are referred to as user equipment. The mobile device itself is essentially a two-way radio that is able to communicate via a radio frequency with a nationwide network of antennas commonly known as cell sites. And to distinguish one mobile user from another, the network must be able to identify individual users. On networks like ours, this is done via a SIM card. SIM stands for Subscriber Identity Module. Once inside a mobile device, it provides the network with a unique code that is linked to an individual user profile. This code is known as an IMSI. IMSI stands for International Mobile Subscriber Identity and is embedded within the SIM card. Shortly after a mobile device is turned on, the device receives information from the SIM card and starts broadcasting information, including the IMSI, to the network. An IMSI is made up of the MCC, the MNC, and MSIN. Let's take a closer look at my IMSI for this example. The first three numbers are known as the MCC, which stands for Mobile Country Code. 530 is the MCC for New Zealand. The next two numbers are the MNC, or Mobile Network Code. 05 is the MNC for our network. The remaining numbers are the MSIN, or Mobile Subscriber Identification Number. This number is unique to each user. Using all this information, the network is able to identify individual users and separate our customers from other mobile devices with inferior SIM cards. Once your IMSI is recognized as a valid user, the connection is established. The device then also provides the network information about its signal strength and its distance from the closest cell site. Upon receiving this information, the network then assigns a radio channel to the device so that it's able to send and receive data to the network. Overseas networks can also recognize when our customers are roaming on their network based on the IMSI. Next up is the radio access network, also known as RAN. Mobile networks have evolved quite a bit since their inception, and you've probably heard of terms like 2G, 3G, and 4G. These are not just marketing terms, but refer to the generation of the network. Generally speaking, newer networks provide improved data speeds and capacity. Our competitors insist on maintaining a 2G network, which makes our network unique in New Zealand as it only uses 3G and 4G technology. This has two main advantages. It's better for our customers because they get faster internet, and it's better for us as 4G networks are more efficient to operate. The physical radio access network is comprised of a nationwide network of cell sites and radio network controllers, or RNCs. Cell sites are spread throughout the country and come in different shapes and sizes to suit environmental and capacity requirements. If you're getting signal on your phone, chances are there's one of these not too far from you. There are well over 1,000 cell sites throughout New Zealand, and new sites are regularly rolled out to improve coverage and throughput. Details about the location, as well as the exact number of sites currently on our network, can be found using our Ventura coverage tool. Cell sites are equipped with antennas that can aim signal into specific directions. And with multiple antennas, cell sites are able to broadcast both 3G and 4G signal at multiple frequencies. The direction in which the antennas are aimed and the location of the cell sites are designed to form hexagon-shaped fields called cells. And yes, this is where the term cellular comes from. Cell sites can broadcast signal over several kilometers, but the actual range depends on a few factors, such as the frequency of the signal and physical obstructions, like buildings and hills. The range is also affected by the amount of traffic going through the cell site. The range can be reduced under heavy usage. In reality, these so-called cells actually overlap slightly to accommodate this and allow for connections to be transferred from one site to another. Okay, that was quite a lot of information to process, and we're only halfway. Time for a quick dance. Alright, with that out of the way, let's talk a little bit about spectrum. Cellular networks operate on the same spectrum as any other device that uses radio waves, including cordless phones, FM radio, terrestrial TV, and Wi-Fi. To avoid interference, different parts of the available spectrum are reserved for specific activities. Mobile network operators like us have to license the spectrum used for their mobile networks. As a general rule, low frequencies travel further than high frequencies. But high frequencies provide a denser signal that supports greater capacity. As a result, our 3G network uses a combination of 850 and 2100 MHz. When we first launched our 4G network, it operated primarily on the 1800 MHz frequency. The 700 MHz band was not yet available as it was previously reserved for terrestrial TV. 4G on 700 MHz is so exciting because it allows us to more easily overlap our existing 3G coverage without having to build hundreds of new cell sites. For more information about the division of radio spectrum in New Zealand, you can visit rsm.govt.nz. Also part of the radio access network are the RNCs. Remember, that stands for Radio Network Controller. Each RNC controls one or more cell sites and act like a hub between the cell sites and the network core. RNCs also control the available radio spectrum and control which cell site your device is connected to. If you're in a location where your phone is in range of 2 or more cell sites, the RNC will determine which cell site your phone actually connects to, based on the signal strength of the device and utilization of the available sites. The RNC also controls the handover process. Handover is required when you're on the move and you need to transition from one cell site to another. The infrastructure connecting the cell sites to the RNCs and the RNCs to the rest of the network is referred to as backhaul. The capacity and quality of the backhaul have a direct influence over the performance and capacity of the network. Finally, let's take a look at the network core. The network core houses many clever systems, and this is where things can get a little complicated. Some of the key tasks performed within the network core are authentication, like determining whether or not the device requesting access to the network is a valid customer. Call control and switching, routing phone calls to the appropriate systems either within our network or passed on to another network. Charging and billing. ensuring customers are charged correctly for their usage of the network. Service allocation, determining which services to allocate to users, like voice, text, or data. And gateways. This is how the network is able to provide internet access between a device and the rest of the world. Two key systems that are housed within the network core are the HLR and VLR, where HLR stands for Home Location Register and VLR for Visitor Location Register. And just to keep things interesting, newer HLRs like ours are also known as Home Subscriber Servers, or HSS. Together, the HLR and VLR manage the users or subscribers on our network. When a number is connected on our network, a unique profile is created and stored within the HLR. This user profile contains information like the user's IMSI and phone number, and is used for things like authentication and managing which services the user has access to. The VLR works together with the HLR and manages all the active connections on the network. It contains a copy of most of the records stored in the HLR, but also stores information about the user's location and mobile status, like if they're busy or available to take a call. When the network first detects your device, it checks the database in the VLR to see if it has a record of the user. And once again, this check is done based on the IMSI. If no active record exists in the VLR, it then requests a copy of the subscriber information from the HLR. There are many other interesting systems housed within the network core, but those might have to wait for another day. Hopefully this gives you a bit of an appreciation of the brilliance and complexity of our mobile network, and join me in looking forward to seeing what's next. Spark you later!